Hello everyone, welcome to video lecture series on microcontrollers and applications. This is lecture number 1, Introduction to Microcontrollers. Today there is no electronic gadgets on the earth which is designed without a microcontroller. In our daily life we are seeing several products which are having microcontrollers. Let us see one example here, personal information products. So there you can see our mobile phones are having microcontrollers, calculators are having microcontrollers, smartwatches, pagers, sound recorders. In addition to this, in our daily life we are using laptops. These laptops may have several components where microcontrollers are used. So in mouse, in keypads, routers, pen drives, and disks. And another applications are home appliances where TV, micro oven, refrigerators, and washing machines. These are some home appliances which may use as the microcontrollers. And industrial equipment where welding machines and car manufacturing systems. There are several robotic arms are working together to manufacture a car, and automatic bottle filling systems and food processing systems. So these are the several applications uses the microcontroller. So that means wherever there is a automation is required, there must be a microcontroller. That's why we need to learn microcontroller as a electronics and communication engineer. So let us see the first definition of a microprocessor. Microprocessor is an integrated circuit that contains all functions of a central processing unit of a computer. A microprocessor is an integrated circuit that contains all functions of central processing unit of a computer, which does not have RAM, ROM, and I/O ports. Examples for microcontrollers are Intel 8086, Motorola 6800, and Pentium series, Pentium 1, Pentium 2, Pentium 3, and Pentium 5. Now we are using Core i3, i5, and i7. These are the microprocessors. A microprocessor is a integrated IC. Integrated IC which have basic components of central processing unit. A central processing unit may have arithmetic logic unit ALU, control unit CU, and some temporary registers. All these are available on a single IC is called as a microprocessor. Then coming to definition of a microcontroller. A microcontroller is a small computer on a single VLSI integrated chip, which includes CPU, on-chip ROM, RAM, I/O ports, some timers, serial communication ports, ADC, DAC, and some other applications required for a particular application. Examples for microcontrollers are Motorola 6811, Intel 8051 microcontroller, Deluxe Z8, PIC 16X series, MSP 430 series, ARM series. These are the examples for microcontrollers. A microcontroller includes a CPU, a central processing unit, RAM, random access memory, ROM, read-only memory, and I/O ports, input-output ports, some timers, serial communication port, some resources required for a specific application are available in a single IC is known as a microcontroller. A microcontroller IC may look like this. Some of the ICs may have dual inline package. Some of the ICs may have quad like quad packages. Quad packages means on four sides of the IC there is a pins are available. Let us see the difference between microprocessor and microcontroller. Integration. So already I mentioned in previous slide, the microcontroller is have CPU, memory, IO chip on chip. In addition to this, some of the resources are also required for particular application is also available on integrated IC. Whereas for microprocessor, only CPU will be available, remaining are externally connected. All the resources required for particular application should be connected externally, including memory and IO ports also. Complexity. The complexity of microcontroller is low and the complexity of microprocessor is very high. Why? Because here we need to connect external devices and the processing ability is also more. So that's why the complexity is high here. Whereas for controller it is low. Why? Because it is used only for lower end applications and it is only suitable for dedicated applications. The power consumption is also low here, whereas for microcontroller it is high. Operating system, usually none, but sometimes we may use free RTOS or VxWorks. But for microprocessors, we use Linux, Windows, Android operating systems we may use. And cost. The cost of the microcontroller is very less. They are available with $10, but whereas microprocessors are very costly. The minimum cost is almost 10,000 rupees. Let us discuss evaluation of microcontrollers. In the year 1976, the Motorola company introduced a microprocessor based computer using 6800 microprocessor with certain add-on chips. This paved the way for new revolution in the history of design and gave the birth for new entity called a microcontroller. This will give the birth to a new entity called a microcontroller. The Intel bagged the credit of producing first microcontroller. Intel stands for Integrated Electronics, which is the first company provided the microcontroller. The microcontroller named 8048 with specifications of a CPU, 1 kilobyte of EEPROM, 64 kilobytes of RAM, 8-bit timer and 27 IO pins in 1976. Then followed the most popular microcontroller, that is 8051 microcontroller, in the year 1980 with the features of 4 kilobytes of ROM, 128 bytes of RAM, one serial communication port and two timers and 32 IO lines. The 8051 family has many additions and improvements over the years and remains almost sought after tool for toy circuit designers. The same Intel introduced a 16-bit microcontroller, that is 8098, in the year 1982. Later, Intel introduced 80C196 series of 16-bit microcontrollers for mainly industrial applications. Later, Microchip, another company, has introduced a microcontroller PIC 16C 64 8-bit in the year 1985. A 32-bit microcontroller have been developed by IBM and Motorola. MPC 505 is a 32-bit RISC controller of Motorola. The 403GA is a 32-bit RISC embedded controller of IBM. And in recent times, ARM company, Advanced RISC Machines, has developed and introduced 32-bit controller, which are high-end application devices, especially communication devices like mobile phones and iPads. Coming to types of microcontrollers, the types of microcontrollers are classified in based on these parameters. First one is bits, number of bits it is handling, memory or IO devices, and family and instruction set and memory architecture. Based on these 5 parameters, the microcontrollers are classified into several categories. Let us see one by one. The first one is based on the number of bits it is handling. They are classified into 4-bit microcontrollers, 8-bit microcontrollers, 16-bit microcontrollers, 32-bit microcontrollers. 4-bit means at a time it will perform operations on 4-bit numbers, whereas in case of 8-bit it will perform operations on 8-bit numbers at a time. Here 16 bits, here 32 bits. Whereas under memory and IO devices, these are classified into embedded microcontrollers and extended memory microcontrollers. Embedded microcontrollers are nothing but within the IC itself, memory and IO devices are available, whereas external memory microcontrollers, we need to connect externally. So that means the memory and IO devices should be connected externally in case of extended memory microcontroller. Coming to, based on the instruction set, these are classified into 2 categories: RISC and CISC architecture microcontroller. RISC is nothing but reduced instruction set computer. CISC is nothing but complex instruction set computer. And in case of memory architecture, these are classified into Harvard and Princeton microcontrollers, architecture microcontrollers. The Harvard architecture is also known as von Neumann architecture. So we will discuss this Harvard and Princeton architecture in next slide, and similarly RISC and CISC also we will discuss in next slide. And based on the family, the microcontrollers may classified into 8051 microcontroller family controllers and Motorola family, PIC family, Hitachi, Texas, ARM, and other microcontroller families. Under 8051 microcontroller family, there are several vendors are there. They are Intel, Philips, Atmel, Siemens, and Dallas. These are the several vendors. They will produce the 8051 family microcontrollers. Coming to memory architectures, already in previous slide we know that these are classified into memory architectures are classified into 2 categories. One is von Neumann architecture, another one is Harvard architecture. The von Neumann architecture is also called as Princeton architecture. If you observe this von Neumann architecture, in von Neumann architecture, only single bus is provided, and the memory is also treated as a single memory unit. So this entire memory is shared by program memory as well as data memory. So that means the program memory and data memory is combined in this case, and both are accessed with same bus. That means This bus can be used as an address bus as well as data bus. Okay. To access the program or instruction, same bus is used. To access the data also, same bus is used. Okay. But in case of Harvard architecture, the separate program memory and separate data memory is provided, and separate buses are also provided for instruction, for accessing the program, for accessing the data. So in case of Harvard architecture, separate buses are provided, but in case of Von Neumann architecture, single bus is provided. And Von Neumann architecture, the entire the CPU considered only single memory IC, but in this case it will consider two memories. One is for program, another one is for data. In case of Harvard architecture. So coming to the differences between Von Neumann and Harvard architecture, the first feature is memory. In case of Von Neumann, the memory is shared for both data and program. For both data and program, it is shared. So single memory is available. Both memories are on shared basis. Whereas for our Harvard architecture, a separate memory is provided for instruction as well as data. Bus. When we are considering the bus, only one bus is provided on shared basis. But here, two separate buses are provided for program memory as well as data memory for accessing the code or instructions or data. Because of this shared memory and shared bus, the memory operations are in sequential, whereas separate memory and separate buses, the accessing of memory may be in parallel. So we can parallelly access data memory as well as program memory, data memory and program memory separately and parallelly. So here this is a slower one. The bottleneck problem is available. Why? Because after fetching the instructions, then only you can access the data. But in this case, faster and simultaneous fetches. That means simultaneously you can fetch the data as well as instruction. So that's why it is a faster compared to Von Neumann architecture. Complexity is simpler here. Why? Because same memory is utilized for the and same bus is also used. But whereas here separate and different memories are used, it's somehow complex as compared to Von Neumann architecture. This memory architectures are used in PCs, general purpose computing, whereas Harvard architecture is used for microcontrollers and DSP processors, digital signal processors. So these are the fundamental differences between two memory architectures, Von Neumann architecture and Harvard architecture. Coming to CISC versus RISC, already we know that CISC stands for complex instruction set computer, whereas RISC stands for reduced instruction set computer. The first feature is instruction set. If you consider the instruction set of CISC processor, it is a large and complex instruction set. It supports large number of instructions and they are more complex. If you consider the RISC architecture, the instruction set is small and simple. And in case of instruction length is varied in case of CISC, but here fixed. So most of the instructions are have same size. The length of the instruction is always, most of the instructions are of same size, fixed length instructions. And the execution time, multiple cycles per instruction. This is based on the instruction. They may have different cycles for completion of one instruction. But in case of RISC architectures, usually only one cycle per instruction. Why? Because most of the instructions are is in same size and all are executed in a single cycle. Hardware. These are more complex. Why? Because of large instruction set and complex architecture, the decoding is difficult, as well as microprogramming is required to translate the instruction to machine code. Whereas here, because of same size, all are simpler and optimized performance. And code size is very small. Because of large instruction set and complex instruction, fewer instructions are required here to perform the given task. Whereas in case of RISC, they require large number of instructions. So because all are of size same or fixed length instructions. The examples for CISC architectures are 8086, Intel 8086, VAX are the examples. Coming to RISC architectures, ARM, MIPS, RISC-V, Spark. These are the RISC type instruction set followed by processors. Usage. Normally they are used for general purpose PCs and servers, whereas RISC architectures are used for mobile devices and embedded systems. Pipelining. Coming to pipelining is difficult due to complex instructions. In case of here, these are easy because of uniform instruction length. Next, criteria for choosing a microcontroller. And one more important thing, when you are developing any application, you need to select a microcontroller. First, you need to consider your application requirements. Then you need to consider processing power of your microcontroller. Processing power is nothing but its frequency of operation. At what frequency it is operating. If frequency of operation is very high, then only the speed of operation is more. Why? Because the frequency is inversely proportional to time taken for the processor to complete one instruction. So as this is reduced, the processing ability of speed of operation of the processor will be improved. That means the speed of the operation or processing power is directly proportional to frequency of operation of the microcontroller. And memory requirement. Then we need to choose the memory requirements. Under memory requirements, what is your code size? How much it is available? So based on your code requirement, you need to choose the EPROM size, and based on your user data, you need to choose the RAM size. So as RAM size is more, your also your processing ability is also more. And when your code size, application code size is more, you need to go with higher memory ICs. Memory microcontroller. Power consumption. This is one of the most important parameter while when we are considering the battery operated systems. So most of the cases the power consumption should be low while selecting your microcontroller. While selecting your microcontroller, the microcontroller should operate with low power consumption. And IO and peripheral devices. IO and peripheral devices. Suppose, for example, if you consider here the number of IO pins available on the microcontroller is limited. But if you require more number of peripherals, in that case, you need to go with higher end microcontroller, which is having more peripherals and connectivity. Whether your microcontroller is having any wireless connectivity, what type of wireless connectivity technology is present in that one? Either Bluetooth is available, Bluetooth or Wi-Fi, or any other communication wireless technology is supported based on our requirement, based on our actual application requirement. Either you require a Bluetooth, Wi-Fi, or IR, or some other wireless technology uh, presented in supported by your microcontroller. Next one is package and size. If the size and packaging should be very less. Why? Because you need to accommodate more number of components if the size of the microcontroller is less in a given space. So that's why how what is the size and what is the package of your microcontroller is also important concern while selecting a controller for a particular application. Next, cost and availability. So when you are developing any product, compulsory cost is matters. Why? Because if cost is less, then only most of the users may buy your product. And one more thing, the availability is also one of the important thing. Why? Because suppose you manufactured 1 lakh products. After 1 year, the company is closed. They are not producing any microcontrollers. So to replace the microcontroller, there is no possibility. So that's why you need to check whether the consistently that company is producing the microcontrollers and they are readily available at any time. So we need to and development tools and ecosystem. And what are the IDE tools? Integrated development environment tools are available, or they are efficiently uh, implement your application. And there is there any ecosystem is support if there is any issue in the IDE. Okay, so these we need to verify. We need to consider while selecting our controller. Another one is the security features. Is this is that controller is having any security features for any malfunctioning or any fake accessing of controller? And then re- reliability and certifications. So this reliability and certification is related to their operating conditions, and certification is nothing but how they are perform during particular operating conditions. So these are the parameters we need to consider during selection of our controller for a particular application. One of the main important thing uh, here we need to consider application requirement. So based on your application requirement, first you need to consider all these remaining points: processing power, memory requirement, power consumption, IO and peripherals, connectivity, packaging or size, cost and availability, development tools and ecosystem, security features, reliability and certification. Now let us see 8051 family comparison. If you observe here, under 8051 family, there are 4 microcontrollers. Let us see. Here I am comparing only 4 microcontrollers: 8031, 8051, 8052, 8751. So these are the features. In 8031 microcontroller, the RAM is only 128 bytes. In 8051, 128, 8052, 128, 8751, it is 256. ROM size is in 8031, no RAM is available, whereas in case of 8051, 4 kilobytes, 8052, 8 kilobytes, 8751, 4 kilobytes UV EPROM. Timers are 2 here in 8051 2, 8052 3, 8751 2. IO ports are in 8031 32, 8051 32, 8052 32, 8751 32. The serial communication ports are in all controllers, only one port is available, and interrupts are 6 most of the cases except 8052. So here these are the family of microcontrollers. Based on our application, we can choose the corresponding controller. Suppose for example, my application requires 8 kilobytes of ROM. So then I need to select this 8052 only. So that means based on our requirement, you can choose a controller based on their available features. The feature of microcontrollers: empowering smarter technology. Microcontrollers are evolving with the increased integration of AI capabilities and with advanced wireless connectivity and driving innovation across various sectors. Because of these advanced AI capabilities and advanced wireless communication technologies, and these applications are covered into several sectors. They include smart automation, wearable technology, industrial automation, and agriculture, healthcare, smart transportation, environmental monitoring, retail and supply chain. Summary of this class. In this class, we discussed microprocessor and microcontroller definitions, microcontroller evaluation, microcontroller types, criteria for choosing a microcontroller, and some real-time applications. Next class, we will discuss architecture of 8051 microcontroller, where you will learn about its CPU, ports, and on-chip resources. These are the simple questions you may practice yourself. What is difference between microprocessor and microcontroller? Contrast RISC and CISC architectures. Define von Neumann and Harvard architecture. And what is the criteria for selecting a particular microcontroller for specific application? Today quote is: a microcontroller may be a small, but in the hands of a learner, it holds the power to build the feature, one real time idea at a time. Thank you.